The floor is yours.
Well, good morning, everybody. My name is Juan, and I'm going to present you my TFM project that is called Dendrochronological Methods Applied to Andean Tree Species Using Ecological Restoration. But first of all, I want to put some context in this. So we're located in the Aburrá Valley, a geographical region located in the northwestern Andes of Colombia. This region is a hotspot of biodiversity. All the northern Andes of Colombia are a hotspot of biodiversity, but it's also a hotspot of historical deforestation. As you can see, is where the Medellin city is located. So in the year 2009, the Medellin City Hall decided to launch the program Más Bosques para Medellin. It was an effort to try to restore these ecosystems that provides the ecosystem services to the population in the Medellin city. So for that, mostly related to hydric solving and carbon sequestration. So in the year 2023, a team from the National University of Colombia headed a above-ground biomass study. So we left up with a lot of samples from the trees that were felled. So we wanted to make like a comparison. We have been monitoring these ecosystems for several years using permanent plots, and now we have like the opportunity to use tree rings to do the same stuff that we were doing before. So we came up with this project, and we want to do dendrochronology in the tropics. And this is our objectives: to first to determine if the species of interest have a periodicity in their diametrical growth and tree formation. Just as Clara previously said, is not a trivial thing, and we're going to have this before. Second, to model the growth as a function of time from the species of interest. And third, to compare the results obtained by dendrochronological methods with previous research that use the data from permanent plots. But, as I was saying, those tropical trees have periodicity in their diametrical growth. This is not a simple thing. For several years, and mostly because dendrochronology has been developed in the template zones of the planet, it was believed that the tropical trees does not form annual or periodical rings. But several studies in these recent years, in the past decades, have proved that trees not only respond, as was believed, to temperature, because in the template zones the temperature varies annually, and that was why the trees formed the tree rings annually. But now we can see that they respond to precipitation, to solar, to luminosity, to cloudiness, to a lot of things. However, there is certain things that we need to address before. That having a rhythm doesn't mean that the rings are formed manually. So we need to precisely know what is the factor that is determining the forming of the tree rings. And for fortunate, we, in this study, know the exact time when the trees were planted. So we can just make like, oh, the trees were planted in 2009, and we are counting to 2023, 14 tree rings. We can assume that the trees are formed annually. And well, I want to introduce you to our subjects of a study that is Juglas neotropica. Juglas neotropica is a species that has been widely used in Andean dendrochronology and has proved to form annual rings. Also, Cedrela montana is part of a genus that has been widely used in the American dendrochronology and also forms annually rings that respond to the dry seasons of the zones that it happens. But we have a problem here with Quercus humboldti. Unlike his cousins in this part of the world, Quercus humboldti is not an easy species to see his morphology. His ring morphology is really complicated, but it's also a really interesting species. It's the only Quercus species in South America, and it forms a stance where it's the monodominant species. So we really want to address this thing and know if Quercus humboldti can have tree rings, so we can develop a lot of more studies, mainly in natural forest. And now we are trying to hit these objectives, the objectives that I told you before, by taking more samples. With these samples, we want to increase our sample size so we can have like a better cross-dating and do a lot of better research, better methods that we had before when I told you with the cakes of trees. So we are now scanning this, but we want to combine it also with a technology that was developed here in the University of Valladolid, that is the capture ring, that will allow us to take more precise photos and to describe better the wood anatomy, determine the morphology of the growth ring delimitation that is mainly our purpose for Quercus humboldti, and proceed with a more accurate cross-dating for all the species. And finally, the Aburrá Valley gladly has a really serious climatic research and a climatic station that has information from several years, so we want to correlate the results in the growth of the species with the historical climatic data that we are getting from this station. And with that, we can determine in a certain way or make correlations of which of the climatic factors that happen in the Aburrá Valley are aheading, and we are perceiving in the growth and the tree rings of the Andean species. So this will be all, and thanks for your attention.